So this is the fifth question related to equivalent capacitance calculation. Okay, we have all 1 microfarad capacitors which are connected in this way. Now, by looking at the circuit, uh, one may think that there is a delta shaped thing involved here. So there will be application of delta to star or star to delta transformation technique, but there is no requirement of that. Okay, it looks a bit complicated. It's not complicated. It looks a little bit of delta. Now this again, these two delta inverted delta shape there. So it is not that complicated if we analyze it in a good way. Okay, again we have to find out the patterns of connection and keep on simplifying and reducing the circuit until we arrive at a two capacitor form. That is the approach. Okay, let us start from one end. Okay, we start from this end. So these two capacitors, the 1 microfarad and this 1 microfarad capacitor, see, they are connected in series. They are connected in series. There is an end-to-end connection pattern. There is an end-to-end connection pattern. These two 1 microfarad capacitors. We are talking in reference to these 2 points A and B. There is an end-to-end connection pattern. It is just like this. Okay, 1 microfarad, 1 microfarad. This way. It looks like this, but if we just uh, flatten it out, it will be actually in this way they are connected. They're in series, the 1 microfarad capacitors. So the equivalent capacitance will be 1 into 1 by 1 plus 1, which is equal to 1 by 2 is equal to 0.5 microfarad, the equivalent capacitance of this combination. So if we simplify the circuit, we will get this shape. Okay, okay, and across this we have this zero point 0.5 microfarad. This is 1 microfarad. This is 1 microfarad. Okay, and this is 1 microfarad. Okay, A and B. This is the reduced circuit. Now, this 1 microfarad and the resultant 0.5 microfarad of these two capacitors, they are in parallel. See, these two capacitors are in parallel because their one ends are connected at one common point and the other end are connected at one common point. So, the equivalent capacitance of parallelly connected capacitors is simply the addition, we know that. So, we will reduce it down as the equivalent capacitance will be 1.5 microfarad, 1 plus 0.5. Now, this 1 microfarad and this 1.5 microfarad, okay, they are connected in series. There is an end-to-end connection pattern. This 1 microfarad and this 1.5 microfarad, they are connected in series. So the equivalent capacitance will be 1 into 1.5 by 1 plus 1.5, which is simply 1.5 by 2.5. If we multiply 10 in both the numerator and denominator, we get 25. So this will be, let's say, 3. If we uh, use 5 as the common, this is 5. This is 3 by 5, which is equal to 0.6 microfarad. Okay, 0.6 microfarad, the equivalent capacitance of these two capacitors. Okay, now again we reduce it. So it will be 0.6 microfarad, which we just calculated. Now you see we have reduced this entire circuit into two capacitor form. Okay, from this point, okay, we reduced it until here. We have reduced this portion into 0.6 microfarad into this two capacitor form. This is the simpler form. Now easily we can calculate the equivalent capacitance as the point between the points A and B. This 1 microfarad and this resultant 0.6 microfarad of this portion, they are in parallel. Okay, they are connected in parallel because one ends they are connected one common point A and the other two ends are connected one common point B. So the equivalent capacitance would be simply the addition of these two capacitances, which is 1.6 microfarad. Okay, 1.6 microfarad. Okay, so this is the equivalent capacitance of this combination or this circuit. Again, with the approach is the same as I have used in the previous solving of the numerical problems of equivalent capacitance. First, you start from a certain end. You identify or find out the patterns of connection of the capacitors. You find out the equivalent capacitance, simplify the circuit, again repeat the same process, find out patterns, simplify the circuit, again find out the patterns, simplify the circuit using series or parallel equivalent capacitance formula until you reach at this simpler form, and then you can find out the equivalent capacitance. Okay.